In this tutorial, I'm going to explain how to do a chi-square test with two variables where you are comparing the distribution of each variable within the other variable. In this data set, my colleague and I surveyed college students about their experiences with online homework systems that required purchase of an access code. In a previous video, I went over how the distribution of students was such that there were more continuing generation students than there were first generation students. Now we're going to follow up with that and see how that distribution of first generation students varies depending on whether or not students say that their grade has been hurt because they could not afford an access code for their homework system. What we'll do to conduct this chi-square test is we will go to Analyze, Descriptive Statistics, Crosstabs, and then when Crosstabs pops up, we're going to put our variables, one in the row and one in the column. So I'm going to do grade hurt, yes, no, in the column, and I'm going to put the first generation yes no in the rows. There it is. And then I'm going to click on statistics and click on chi-square so I can get the statistics reporting. I don't need to worry about these other ones. Click continue and then click OK. And what we can see here is we have it distributed where it shows the marginal means, where this is the marginal counts, which is this is the number of students who are continuing generation, first generation. The number of students at the bottom of this row are the grades were not hurt but because they couldn't afford an access code. And then here, what the students where their grade was hurt. Now, within these students, we can tell just by looking, we see that the number of students whose grade was hurt is the same for continuing generation and first generation. However, there are considerably more continuing generation students than first generation students. And what we can see is we'll use Pearson's chi-square test, and our Pearson chi-square is 13.902. This is highly significant. It is the significance value is less than 0.001. That is our p-value there. So we can confidently say that there is a difference in the distribution here. Now, just reporting these numbers can be a little confusing to try to keep track of all those counts in your head. So reporting the statistics of percentages within those cells can be really helpful. What we're interested here is percentage-wise, what percent of continuing ed students say that their grade was not hurt, and what percent said their grade was hurt, and then same thing for first gen. So we're interested in these rows and how this distribution is different for first generation students. So we're going to go to Analyze, Descriptive Statistics, Crosstabs, and we already have our chi-square checked. Then we go to cells, and where it says percentages, we'll click on row, click OK. And here you can see that 20.4% of continuing generation students say that the grade was hurt, but over 50% more. So 31.7, this is 11.3% more of students who are first generation said that their grade was hurt. So what you could argue based on these findings is that requiring students to pay for access codes is disproportionately harmful to first generation students compared to continuing generation students. So that is how to conduct a chi-square analysis where you have two variables. And real quick, degrees of freedom here is 1. That's because with a chi-square with two variables, you take the first variable, number of categories minus 1, times the second variable, number of categories minus 1. So this would be 2 minus 1 is 1, 2 minus 1 is 1, 1 times 1 is 1. With a chi-square, we do not have degrees of freedom reported for the number of participants. We just have it for the number of categories within each variable.